Okay, let's do an example of S parameter properties. The two properties that we looked at previously, the introduction of it, first property is known as lossless or lossy, and the second property of S parameter is the network is reciprocal or not. So in order to check the reciprocity of my S parameters, the first thing I need to do, I need to take the transpose of that. If the S parameter is equals to the transpose of this matrix, then I know that this is reciprocal. And since this is quite an easy example, you can actually see the main diagonal, they are quite similar, which means it is reciprocal. In order for me to find out if my network is lossless or lossy, it needs to fulfill this condition. And the condition for this is it is this: the transpose of this matrix multiply by dot product with the conjugate of this matrix should give me an identity matrix or a unitary matrix. All right, so in order for me to find out if my network is lossless, these S parameter, whichever network is based on, is it lossless or lossy, I need to fulfill this condition. When I take a dot product with this or simply multiply them together, the transpose of a matrix times the conjugate of that matrix, I should get unitary matrix, where in my main diagonal I have ones and then I have zeros. All right, so let's do this. So in order for me to do that, once we do the lossless and lossy condition, I would know I need to take a transpose of this. So let's take a transpose of this. So let's do it here. So the transpose of this matrix, S transpose of this matrix, is going to be 0.2. In transpose, what we do, whatever we have in terms of rows. So how many rows are there? There are 2 rows. I'm going to write the first row in terms of column. So 0.2 plus j 0.4. This is that first row, row 1. So let's call this row 1. This is row 2. This is C1, C2. All right, so row 1 I'm going to write as column 1. So row 1 is 0.2 plus j 0.4. I'm going to write it in terms of column, which is 0.8 minus j 0.4. So row 2 I'm going to write that in terms of column as well. So 0.8 minus j 0.4. Row 2 I'm writing it as a column, 0.2 plus j 0.4. So indeed it is a reciprocal network. We can easily visualize this using this, but by fulfilling this condition, when you take a transpose of this is exactly the same thing, which means my network is reciprocal. All right, then I need to take a dot product with the conjugate of this matrix. So in the conjugate of this matrix, what I'm going to do, I'm going to pick up this and I'm going to change the sign. That's it. The conjugate is change the sign, which is in the middle. So 0.2, it will become negative j 0.4. This would become 0.8 plus j 0.4. All right, this would become 0.8 plus j 0.4, 0.2 minus j 0.4. So this is the conjugate. So this is the transpose of the matrix, of this matrix, and dotted with the conjugate of this matrix. All right, so what is the condition? So what do I need to do? I will take row number 1 and I multiply with column number 1. I'm going to take row 1 and I'm going to take column number 2. I'm going to take row 2, I'm going to take column number 1. I'm going to take row 2 and I'm going to take column number 2. So this is how am I going to do it. So this is what I'm going to do. So now I have to take a dot product, or I need to multiply this matrix by this matrix. If the answer of that matrix is I, which is identity matrix in a form of 1s, 1 and then 0 in diagonal, then if that is true, then I know for sure that this is a lossless network. as soon as I get any other value beside 1 and 0, I will drop that matrix. I will drop this and I will consider this as being a lossy network. So in order for me to do that, I'm going to do this. Row 1. So let's call this row 1, row 2. All right. So I'm going to take row 1. This is called that column 1, column 2. So row 1 multiply by row 1 on the transpose matrix times it by column 1. So this is going to be 0.2 plus j 0.4 multiply by 0.2 minus j 0.4. So this multiply by this plus 0.8 minus j 0.4 . Okay, 0.8 minus j 0.4 times it by 0.8 plus j 0.4. All right, so I'm going to do the same thing now. Row 1, column 2, row 1, column 2. I'm just simply multiplying it, the transpose matrix with the conjugate matrix. So 0.2 plus j 0.4, this is row 1, multiply by column 2, which is 0.8 plus j 0.4 plus row 1 0.8 minus 0.4 times it by 0.2 minus j 0.4. All right, then I'm going to take row 2, which is this guy, and I'm going to multiply with c1 and c2. So row 2 times c1, so which is 0.8 minus j 0.4, then c1, which is 0.2 minus j 0.4, which is this guy, plus 0.2 plus j 0.4, which is this guy, multiply by this 0.8 plus j 0.4. I will get some value. We'll calculate this a little bit later. So row 2, then we will have c2. So 0.8 minus j 0.4. All right, so far so good. Multiply by this guy, 0.8 plus j 0.4. This guy multiply by this guy multiply by this, plus 0.2 plus j 0.4 multiply by 0.2 minus j 0.4. All right, so once I calculate this, I should get a unitary matrix. And so in order for me to do that, so all I need to do is just use my calculator and plug in the values. All right, so I'm just going to simply use my calculator to plug in the values. So I have my complexes on. The way we're going to plug it in is this. I'm going to put a bracket. So 0.2, 0.2, 2 plus 0.4, 0.4, and there's a symbol alpha I for this, plus multiply by 0.2 minus 0.4. Let's do 0.4 alpha I, that is this, plus 0.8, 0.8, let's put a bracket around it, 0.8 minus 0.4, 0.4 alpha I, put a bracket around it, 0.8 plus 0.4 alpha I, put a bracket around it and put a whole bracket around. The answer that I'm getting is 1. So in this way, you calculate all of these values. So the first one is 1, and this value, this you would get 0. You will get 0, and I believe this you will also get 1, and you will get 0. Okay, so now the unitary matrix would look something like this. So when you take a dot product of this, you'll get a unitary matrix. So this is how this is going to be. 1, I think this is going to be 0 when you calculate this. So 1, 0, 0, 1. Since this is a two-port network, that's why I have 4 values. When I multiply this by this, these are the values I'm getting it. When I put it in a matrix form, this is how it looks like: 1, 0, 0, 1, which means the main diagonal is 1. This thing is 0. That means my network is a lossless network. Based on the values that I'm getting, there is no loss in my network. And this is how you check based on S parameter if my network is lossless and if my network is reciprocal. These are the two important properties that we look at when we observe the S parameters. I hope you like this small tutorial on S parameter properties with respect to an example. How do you actually calculate and plug in the values? If you have any questions, please leave it in the comment section, and don't forget to subscribe to my channel.